Fellow gardeners, have you ever wondered if there's a secret weapon hiding in plain sight that could transform your garden from average to absolutely extraordinary? Well, let me tell you, there just might be. I've been experimenting with something that might sound like science fiction but is actually grounded in brilliant agricultural science. The Johnson-Su Bioreactor isn't just another composting method, it's a complete paradigm shift in how we think about creating living soil. After months of research and hands-on experimentation, I'm convinced this could be the most important tool in your gardening arsenal. The Johnson-Su Bioreactor represents a breakthrough in microbial cultivation that goes far beyond traditional composting methods. It's truly fascinating how it works. Developed by Dr. David Johnson at New Mexico State University, this system creates an environment specifically designed to cultivate beneficial fungi alongside bacteria in perfect harmony. Unlike hot composting, which often kills beneficial microorganisms, the Johnson-Su method maintains optimal moisture and oxygen levels while never exceeding temperatures that would harm the delicate microbial communities we're trying to nurture. It's quite an amazing process, really. What makes this system truly revolutionary is its ability to produce what scientists call fungal-dominated compost. Most traditional composting methods create bacterial-dominated environments, but the Johnson-Su reactor's unique design promotes the growth of mycorrhizal fungi and other beneficial soil organisms that form symbiotic relationships with plant roots. These fungi extend the reach of your plant's root systems by thousands of times, dramatically improving nutrient uptake, water retention, and disease resistance. Building your own Johnson-Su bioreactor requires careful attention to specific dimensions and materials that ensure proper airflow and moisture retention. The foundation starts with a base approximately 4 feet in diameter, constructed from hardware cloth or welded wire mesh to allow for crucial bottom aeration. The vertical structure rises to about 3.5 feet, creating the perfect volume-to-surface ratio for microbial activity. So, the magic really happens in the layering system. You'll need about equal parts of carbon-rich materials like shredded leaves, wood chips, or even paper, and nitrogen-rich materials such as kitchen scraps, fresh grass clippings, or livestock manure. Now, the key difference from traditional composting is in the moisture content and the inclusion of a perforated aeration tube running vertically through the center of the pile. This tube, which is usually made from PVC with holes drilled every few inches, ensures a steady oxygen flow throughout the entire mass, and you won't even need to turn it. The construction process does require a bit of patience and precision, honestly. As you build your layers, you want to keep the moisture levels about like a wrung-out sponge, moist but not dripping wet. The bioreactor should feel substantial but not compacted, so air can flow freely while still keeping that close contact between materials that really encourages microbial activity. Once it's filled, the whole structure gets capped with finished compost or garden soil, which creates a living blanket to help regulate both moisture and temperature. In just the first few weeks of operation, your Johnson-Su bioreactor becomes a bustling metropolis of microscopic life. The conditions you've carefully maintained create an environment where beneficial bacteria, fungi, protozoa, and all sorts of other soil organisms can thrive in perfect balance. Unlike the intense heat you might get with traditional compost piles, the Johnson-Su method keeps temperatures between 100 and 130 degrees Fahrenheit, warm enough to break down organic matter efficiently but gentle enough to preserve those delicate, beneficial microorganisms. So, the real excitement begins around month 3 when you start seeing visible fungal networks, those white, thread-like structures called hyphae, spreading throughout the material. These aren't just signs of decomposition, they're actually indicators of a thriving ecosystem that will dramatically enhance your soil's biology. The fungi work in partnership with bacteria to break down complex organic compounds into forms that plants can readily absorb, while at the same time creating stable soil aggregates that improve drainage and water retention. What's particularly fascinating is how the bioreactor creates its own internal ecosystem. Beneficial insects and worms naturally move in, further enhancing the decomposition process and adding their own valuable contributions through castings and tunneling activities. The result is a complex, living system that's constantly working to transform raw organic matter into the most bioactive soil amendment you can imagine. After 12 to 18 months, your Johnson-Su Bioreactor will have transformed into what I can only describe as gardener's gold. The finished product bears little resemblance to the raw materials you started with, having been converted into a dark, earthy-smelling substance teeming with beneficial microorganisms. The harvesting process is straightforward but requires some planning to preserve the microbial populations you've worked so hard to cultivate. When applying this bioreactor compost to your garden, less is definitely more. Unlike traditional compost that might be applied by the wheelbarrow load, Johnson-Su compost is so concentrated with beneficial biology that a thin layer of just 1/4 to 1/2 inch can dramatically improve soil health. The key is to apply it when soil moisture conditions are optimal, and to avoid disturbing the soil afterward, allowing the introduced microorganisms to establish themselves in their new environment. The results speak for themselves. Plants grown in soil amended with Johnson-Su compost consistently show improved growth rates, increased disease resistance, and enhanced nutrient density. The mycorrhizal networks established by the fungi create what scientists call the wood wide web, a communication system that allows plants to share resources and information, creating a more resilient and productive garden ecosystem. The true power of the Johnson-Su Bioreactor becomes apparent not in the first season, but in the long-term transformation of your garden's soil ecosystem. Unlike synthetic fertilizers that provide a quick nutrient boost but do nothing to improve soil biology, the bioreactor creates lasting changes that compound year after year. The beneficial microorganisms introduced through the compost continue to reproduce and spread, creating a self-sustaining cycle of soil improvement. One of the most remarkable aspects of this system is its ability to sequester carbon while improving plant health. The stable organic compounds created through the Johnson-Su process remain in the soil for years, gradually releasing nutrients while building soil structure. This means your garden becomes not just more productive, but also more environmentally beneficial, actively removing carbon dioxide from the atmosphere and storing it in the soil. The investment in time and materials required to build and maintain a Johnson-Su bioreactor pays dividends that extend far beyond a single growing season. As your soil biology improves, you'll find yourself relying less on external inputs while achieving better results. Plants become more resilient to drought stress, pest pressure decreases, and the overall health and productivity of your garden reaches levels you might not have thought possible. Your journey into advanced soil biology starts with that first bioreactor, but the benefits ripple outward season after season. If you're ready to take your gardening to the next level and join the growing community of gardeners discovering the power of living soil, make sure to subscribe to the Living Soil Lab for more in-depth experiments and practical applications. Share this guide with fellow gardeners who are ready to transform their approach to soil health. Together, we're building a more sustainable and productive future, one garden at a time.